Understanding that the alcohol act as an electrophile as well as nucleophile, we will now go in the detailed study of its chemical properties by taking the first set of reaction wherein we find a cleavage between oxygen and hydrogen. Here we understand that alcohol readily tends to give hydrogen ion, hence it shows acidic properties. To take up with this study, we are seeing the first set of reaction, that is the reaction with metals. Here we have the first reaction wherein we have a alcohol reacting with sodium metal in order to give you sodium alkoxide and hydrogen gases released. This can be also carried out in a laboratory under proper precautions. If you drop a small sodium metal piece in alcohol, you find that effervescence of hydrogen gas being released with the formation of sodium alkoxide. We also find a similar kind of a reaction with aluminium metal. Now, aluminium reacts with alcohol in order to form aluminium alkoxide. We have taken an example of ethanol here. So, it is going to form aluminium ethoxide with the liberation of a hydrogen gas. We have to understand here that since the valency of aluminium is 3, we will have 3 moles of alcohol which will be taken per 1 mole of aluminium. Since 2 mole of aluminiums are involved over here, we will have 6 moles of alcohol being used in the reaction. This is another set of a reaction which is also there in our textbook, wherein we find that tertiary butyl alcohol reacts with aluminium to give us aluminium tertiary butoxide with the liberation of hydrogen gas. So, this 3 reaction shows us the acidic nature of alcohol wherein hydrogen is being cleaved from oxygen, thus giving out hydrogen gas. A similar kind of a reaction is also observed in case of phenols. We see 2 such reactions here in which we have our phenol reacting with sodium metal to give us sodium phenoxide with the liberation of a hydrogen gas. Similar reaction is seen with our phenol and that of sodium hydroxide giving us sodium phenoxide, and OH reacts with hydrogen to give us water. This makes us more prominent to understand that it goes to show us a acidic nature which is represented in this general equation. We say that alcohols and that of phenols act as Bronsted acid. We know about the various theories of acids and bases being put up. So, we also know about the Lowry-Bronsted theory. Here we thus mention alcohol as Bronsted acid which is abstracting hydrogen. So, over here base can abstract the hydrogen, thus the base forms a conjugate acid and our alcohol forms the conjugate base. That is, if I am having any alcohol present over here, it goes to form a alkoxide. Let us take the base is sodium hydroxide. In that case, it is going to form water over here and will form sodium alkoxide over here as its byproduct. Okay. So, which is nothing but a conjugate base of our acid, that is our alcohol. So here are the set of a reaction in which we go to understand the acidic nature of alcohol as well as phenols.